All
All right,
right, then
welcome
we're
back,
back.
everybody. Let's go ahead and start in and take a look at these. 22A, Group 1. Go ahead.
So the area represents the probability that C is going to be in between those numbers, and the probability would be 48.38% in this case.
How'd you find it?
We found it by putting negative 2.14 comma 0 in the normal CDF, and then you multiply that by 100 to get a percent. And then the graph just the area in the graph represents that probability.
Perfect. So yeah, so see, the first thing I want, ideally always the first thing I want you guys to do is draw a picture. So draw a picture, put in your z-scores. So they put z-score, zeros right in the middle, and they shade it between them. And then that helps you tell yourself what to do normal CDF of. Perfect. Good. Number B is 22B is group 7. Go ahead.
So for B, we first started by doing normal CDF, by then doing 0.29, and then 100, which represents just a number, represents infinity.
Yeah, okay, that's close up to infinity, sure. Yeah.
Then we got 38.59, and then we shaded it.
Percent. Don't forget the percent.
Percent, yeah. And then we shaded it to the right to represent the population that's bigger than 0.29.
Okay, good. So here's their normal curve, their line, 0.29, and then they shaded to the right. Okay, good. And then group 4, you guys were doing this one. Go ahead.
You see, we came forth putting together the calculations when we were given the problem between Z and equaling what 1.09 and 1.83. We put in that small cluster. We put in that small cluster there and have the lower as the lower and the upper as the upper, and we just kind of set up the mean and the standard deviation, and we just kind of punched that in the calculator, and the calculator gave us that answer.
Okay, and then your picture?
That is the picture.
Okay, well, there you go, there's the picture. Yep, so again, you've got your curve, and you have your just a little dash at 0, and then 1.09, 1.83, the two things you care about, and then you shade in between them. Okay, you guys are fine, that's good. Group 3, problem 23, go ahead.
So you know that the negative 1.43 is your lower point that you're going to be using because Z is greater than that. Yeah. And then 0 would be your upper. So when you plug it into the normal CDF, use that as the lower and the upper. So it gives you 42.36%, and then you shade in between to find the area.
Okay, great. So again, they shade in between these two. Good. Let's take a look at where we are here. So now we're going to get into something I kind of want you guys to point out. I want to point out for you guys. So how about Grace, do you want to go and read for me?
Yeah, to summarize one main point, the area under the curve equals the probability, which equals the percent of population in that range. Do you want me to read the example?
Yeah, please do.
Okay. Area under curve between -1 standard deviation and +1 standard deviation is equal to the probability of -1 is less than Z.
Oh,
which
sorry.
Is
probability that Z is between -1 and 1. Sorry, my bad.
Okay. Which is also equal to the percent of population that lies between -1 standard deviation and +1 standard deviation, which are all about 68% or 0.68.
Right, so these are all the same thing. The area underneath the curve is the same thing as the probability, which is the same thing as the percent of population that's in this range from here to here. Those all mean the same thing. And actually it's also the same thing as the cumulative relative frequency as well. All four of those things kind of represent the same thing in normal distributions, right? This area underneath the curve, it's the same thing as the probability because it all adds up to 100%, 1 or 100%. It also stands for the percent of the population that lies between those two. negative 0.9, right? This is, you know, kind of a little bit clearer, right? Area of the curve, same thing as the probability of being between these two. And also the percent of the population that will lie between these two z-scores. Okay. So that was your quiz problem number 1, incidentally. All right, so applications of the normal distribution. So if you did not write this down earlier, you need to have this. This is information you absolutely have to have to solve the next few problems we're going to be doing. So solving problems using the standard normal distribution. All you have to do, because usually when we have something, we don't say, well, I'd like to know what percent of the population has a z-score between blank and blank. I actually say something like, I want to know what percent of the population have heights between, you know, 54 inches and 59 inches, right? You usually have some values. So all you have to do to use what we've been doing before, this normal CDF, is convert your values to z-scores and then pop them into what we've just been doing. So how do you find a z-score? Again, it's your value minus the mean over standard deviation. If you did not write that down earlier, write it down now because you will need it in about 2 minutes. Let's go ahead and do an example. Let's get, who hasn't read today yet? Aiden, go ahead and read for me.
Example, liters of blood. An adult has an average 5.2 liters of blood. Assume the variable is normally distributed and has a standard deviation of 0.3. Find the percentage of people who have less than 5.4 liters of blood in their system.
Perfect. Thank you. So convert values. So this, we are, if you weren't sure, we are now right here, area under the curve. So we've just done this part, right? That was the last slide here. I'm gonna shut you guys up because some of you guys are talking. And now we're working on this part right here, applications and normal distributions. So first, we're going to convert our x values to z-scores. And then second, we're going to draw a picture. And third, we're going to use normal CDF to find the area between the two z-scores. So all we're really doing is adding one step in front of what you've been doing, converting x values to z-scores. All right, so what are the x values that I care about here? 5.2, that's not a value I care about. I'm saying find the percentage of people who have less than 5.4 liters. That's the number I care about. This is part of my general information. This is my average. That's my mu. This is my standard deviation. This is my sigma. Right? So these are just pieces of the problem of the information. What I want to do is find the percentage of people. So the finding percentage of people, this here, this part here, this is my problem right there, the part in yellow. So I need to first figure out what do I care about? I care about less than 5.4 liters. So 5.4 is my x value. I need to convert it to a z-score. How do I do that? Find out, figure out how far it is from the mean. The mean is 5.2. That's my average. Average is mean. So how far is it? 0.2 liters. I need to get that in terms of standard deviations. 0.2 liters is how many standard deviations? I don't know. Divide by standard deviation, you'll get it. So, oops. So 5.4 minus 5.2 divided by my standard deviation, 0.3, I get 0.67. Okay, I want less than 0.67. So I'm going to draw a picture, put in 0.67, and shade to the left of it, less than it. So here's my picture, 0.67, straight up, shade to the left. I do not like this line here, but I can't get rid of it. So just kindly ignore this line here. Should only have one line at 0.67. Okay, and then we're going to do normal CDF. Right, normal CDF of, well, what's the z-score way out here? Well, way out there, it would be negative infinity, right? So use any large number you want. So I will probably do something along the lines of normal CDF of negative, I don't know, 100 or 200, comma, 0.67. Let's see what I get if I do that. Actually, I can't do that. On normal CDF, sorry, let me go ahead and do it from the beginning. Second vars, normal CDF of negative is down here. Don't forget, it's not the minus sign, it's this negative symbol down here, negative 200, comma, 0.67. And I will get 0.74. Oh, look, they gave it to me. 0.748. Don't, it's not 85. You gotta look at the next decimal over. It's 7, so you're gonna round up. 0.7486. Good.
Professor Young,
Yeah. Yes.
say the lowest number, the low number is actually like a bigger number that you put in the calculator. Would it affect the percentage?
What do you mean?
Would it have a different answer?
If I did
0.74?
If I did like say negative 10?
Or no. Oh yeah, actually.
Sure. Negative 10? Nope, it won't.
Okay. Thank
Look.
you.
See, it's totally the same. Look at that.
Okay.
Any z-score you have that's larger than 10 is huge. A z-score of 10 is like impossible almost. So it's not going to affect your probabilities at all. If I did a normal CDF of, well, that's right, I'm not going to, well, yeah. If I did normal CDF of negative 1 million, or else pick some really big number, I'll just put a bunch of 9s in, comma, I don't know, like 5, 6, I think 6. I'm probably going to get 0. Oh, sorry, I did positive. Oops, my bad. I'll try it again. Second vars, normal CDF, negative 999999999, comma, negative, I better do never 7, and I think that should give me 0, right? So it's it's a whole, it's 12 zeros and then 1. It's like, it's nothing, right? So there's nothing between those, because really, once you get beyond 3 or 4 standard deviations, you've got practically nothing out there. Once you get beyond 5 standard deviations, there's hardly anything, and definitely beyond 7, there's basically nothing.
Okay, thank you.
Yeah, sure. Okay, so let's go ahead and do, let's have you guys do an example. So you guys are going to do lab problem 24, A, B, and C. Here are some hints. Listen up to the hints. Focus, guys. Hints are 27 and 31. Those are your X values. You need to find the Z-score for 27, and you need to find the Z-score for 31. What's my mean? My average, right? My average is 28. My standard deviation is 2. Right, so find your Z-score for 27. Find your Z-score for 31. Draw a picture for them. Put those Z-scores in and shade between them. Less than means lower. More than means to the right. All right. That is it. Go forth and conquer. All right, welcome back. Let's go ahead and take a look at A and B. So A, first they found the Z-score for 27. 27 minus the mean, right? Average of 28, that's the mean. And then the standard deviation of 2. And they found it has a Z-score of negative 0.5. And they found the Z-score for 31, right? 31 minus the mean divided by the standard deviation, 1.5. Then they found they drew a picture, negative 0.5, positive 1.5, shaded between them. I don't care if it's accurate or not, just, you know, this is on this side of 0, this one's on the other side of 0, that's close enough, that's fine. Normal CDF of those two scores, 0.6246 or 62.47%. Terrific. Again, if your group didn't get it, make sure you write it down and you get it down now. And then for B, 28.5 pounds minus the mean divided by the standard deviation, 0.25. So less than, aha, this is where it gets confusing. So less than, so this -20 is really far away. It's like, it's way out here. So the shading should go, these sticks should go, oh, if I can't grab them. All right, anyway, they should go all the way, it goes all the way to the end. Shading goes all the way to the end. Because -20 is way, way out there. And same thing over here. This goes all the way to the end. Because 20 is really way, way, way out here. Oops, my bad. It's way, way, way out here. Way out there. Okay. Good. So basically from -infinity to 0.25, and that's 59.87%. And then you found the z-score for 30.2, 1.1, and you want more than, so it's more than is to the right. So it's 1.1 to positive infinity, or just 20, that's fine, 13.57%.
Actually, do have a question. Where did the 20 come from? Because I just used.
They just picked a number, a large number. That's all they did.
I just typed in like infinity 9, like the 3 9s, and it gave me similar answers for C, but slightly different answer on B.
That shouldn't matter. So we'll go through that. Hold on. Let's take a look at B. It's fine. So you're doing on, second vars, normal CDF, and you just pick any large negative number. So negative 999, comma, 0.25. Yep, 0.5987. Did you do a negative number? Did you do Z? What did you, so at any rate.
I used positive. Sorry, I forgot about the negative.
Ah, that would be why. Great. Because it's less than. So it's got to be negative. Okay, great. Looks good. So then we're going to take a look at the next sort of section we're doing. So let's get a reader for that one. How about Serena? Go ahead and read for me.
Sometimes you will want to find a z-score where a certain percentage of the population lies above it or below it. In this case, you are given an area or percentage and want to find z. Here are some situations where you are finding a z-score.
Perfect. Thanks. Jacob, can you read for me the next one? Jacob D. Jacob Dennett. All right, how about Olivia? Go ahead and read.
Find the z-score so that 98.87% of the area under the distribution curve lies to the left of it.
Or? These are just examples. Keep going.
Or 82.12% of the area under the distribution curve lies to the right of it. Or only 10% of the population is greater than or equal to it.
Right. In other words, it's a cutoff for the top 10%, and that's one that comes up pretty often. So let's take a look. Oops. Yep. So we're going to use our TI calculator and inverse norm to find the z-scores for areas, to find the z-score for an area on the left side of a normal curve. So how you do that, let's show you how to do it first. So you do second vars. You'll go down to inverse norm. and hit enter. Now, inverse. An inverse is something that undoes something else, an inverse function. So for example, the inverse of addition is subtraction. What's the inverse of multiplication?
Division.
Division. Great. So the inverse of normal CDF is inverse norm. So what happens is normal CDF, we feed it z-scores and it spits out an area. Inverse norm, you feed it the area and it spits out the z-score. It's a little bit complicated in the following way. So here is sort of my normal distribution. And I want an area, say I want to know an area where, I want to know what the z-score is if the left area here is 0.025. So my area right inside of here is 0.025, 2.5%, right? This is 2.5%. So that's this right here, 2.5%. And I want to know what the z-score is for that. I want to know what's the z-score such that 2.5% lies to the is less, is less than that. 2.5% of the population is less than it. So here, I can do inverse norm of 0.025. Go over here, 0.025, and it'll give me the z-score, negative 1.96, which is sort of what we expected, right, in a sense, because if you guys remember, it should be about 2, because remember from last class, we found that 2 standard deviations, about 5% would be on the outside, about 2.5% on the left, and about 2.5% on the right. So this should be about 2, and it's negative 1.96 to be perfectly accurate. So this inverse norm, if you feed it an area on the left, here's the problem. You have to feed it an area, and doesn't know whether this area is in the middle or on the right side or where in the middle. So we just have said it's always going to be the area on the left tail, because you have to have it with the area 2.5% here is a lot different than 2.5%, like here, right? Or 2.5% here. You have to have some sort of standard place for it to be. So they've said, well, cumulative is usually the most important thing. So from infinity, negative infinity up to here is your area, is the 2.5%. So that's how you get it. Let's go ahead and let me take a picture of this actually, before I forget. Let me go ahead and clear this. And have you guys do some problems. So I'm going to do one problem with you. I'll do B. So this is problem 25. I'll do B with you guys. So first, 10% of the population is greater than or equal to it. In other words, it's a cutoff for the top 10%. So draw your picture first. Is my 10% on the left or the right? Is it on the top or the bottom?
Top.
Yeah, top. 10% is greater than top 25. So here, this is 10%. So I'm going to put in my little text box. I'll change colors. This here is 10%, right? 10%. Oops. Oh, white isn't going to help me out. There, red. Good. That's 10%. So here's the problem. Inverse norm only takes stuff, unless you have the fancy 84s. So if you have fancier 84s, then you could use 10% and put right tail. But if you don't have the fancy 84, like what I've got, then you have to say, you have to give it the left area. So if 10% is on the right, then what is the area on the left? Here's my z-score. Okay, my z-score is smack dab here in the middle. 10% to the right of it. What percent is to the left of it?
90?
90%, exactly. 90% or 0.9. 0.90, 0.9, whatever. Either one's fine. So I'm going to put in second vars. Oh, let me clear it first. Second vars, inverse norm, and I'm going to feed it 0.9, 0.9, 0.90, same thing. And it's going to give me 1.28. That means the z-score for here is must be 1.28. And we're going to, again, use that same convention that we use 4 decimals for the areas. We use 2 decimals for the z-scores. You guys okay with this? So you guys are going to do 2 of them. You're going to do A and you're going to do C. C is a little bit tricky in that I didn't give you the area to the left. I gave you the area kind of in between. You need to find this little area here first. So you know some stuff about normal distributions. This is smack dab in the middle. You know some stuff about this area, this big area here. You should be able to find this small area here. All right, so just 4 minutes in your rooms, and then we'll pull you guys back in. Maybe 5.